In a battery, a spontaneous chemical reaction occurs to produce electrical energy. An electrolytic cell can make a non-spontaneous reaction occur by providing electrical energy and converting that to chemical energy. We know metals lose electrons. Some metals lose electrons easier than other metals. So stop the video and answer these questions. And here are the answers. If we connect one metal to another metal, electrons will flow from the more active metal to the less active metal. When copper is placed in a zinc ion solution, no reaction occurs. That's because copper does not lose electrons as easy as zinc does. However, we can use electricity to make this non-spontaneous reaction occur. When zinc is placed into copper ion solution, a reaction will occur, and we'll see copper metal get plated onto the surface of the zinc. Placing copper into a zinc ion solution is not a spontaneous reaction. So how can we use electricity to plate zinc metal onto the copper? So stop the video and think about how you would do that. And here are the answers. So here is our copper electrode, here is our zinc electrode, and both electrodes are placed in a zinc ion solution. We want zinc ion to be reduced to zinc metal on the surface of the copper electrode. So we would connect the copper electrode to the negative terminal of the battery. That forces electrons from the battery to the copper electrode. Those electrons are going to be gained by the zinc ion to turn it into zinc metal. The plus terminal of the battery we connect to the zinc electrode. The zinc will be oxidized to zinc ion, and the electrons lost by the zinc will flow through the wire toward the battery. Note that the zinc ion is being reduced to zinc at the cathode. The zinc metal is being oxidized to zinc ion at the anode. That means there's no overall reaction, which means that the minimum voltage required for this reaction to occur is 0 volts. Because of resistance in the cell, some voltage needs to be applied to make this reaction occur. You're having some guests over for dinner, and you want to impress your guests with your silverware. Problem is, your silverware isn't silver. You can fix that. So stop the video and describe how you would set up this electrolytic cell. So here are the answers. So here's your iron spoon, and you want to reduce silver ion to silver metal on the surface of your spoon. Make sure you connect the spoon to the negative terminal of the battery. That's going to force electrons into the spoon, which will supply the electrons to the silver ion to reduce it to silver metal. This calculation shows that current and time determine the mass of silver that's plated onto the spoon. An electrolytic cell can be used to split water. So stop the video and describe an electrolytic cell to split water. So here are the answers. Usually an inert, unreactive substance is used as the electrodes, for example, graphite or platinum. Connecting this electrode to the minus terminal of the battery is where reduction will occur. The water will be reduced to H2 gas. At the other electrode, oxidation will occur. That's where water will be oxidized to O2 gas. We need to add an electrolyte to the water to make sure ions flow from one electrode to the other. So usually it's sulfuric acid or sodium hydroxide. For the minimum voltage, here are the half reactions that occur under acid conditions and under basic conditions. Under acid conditions, H plus is reduced to H2 gas, and H2O is going to be oxidized to O2 gas. Under base conditions, water is reduced to H2 gas, and hydroxide is oxidized to O2 gas. In each case, E cell is minus 1.23 volts. Is 1.23 volts a lot of energy? This calculation, energy equals charge times voltage, says it actually is. Delta G, which is 237.4 kilojoules, tells us non-spontaneous, also a lot of energy. 1 mole of photons of red light has the energy of 184 kilojoules. For blue light, it's 266 kilojoules. If electricity costs this much per kilowatt hour, it would cost this much to split 1 mole of water, or that much to split 1 liter of water. Splitting 1 liter of water produces 111 grams of H2. That H2 can be used as a fuel in a combustion reaction. That 111 grams of H2 produces 15,800 kilojoules. Note that the net is going to be 2,600 kilojoules by splitting water and using the H2 as fuel. This is one reason why many people think hydrogen is the fuel of the 21st century. We use a lot of energy each year. The thing is, that's the amount of energy from the sun that strikes the earth in 1 hour. Currently, solar cells are not very efficient. 14% efficiency means for every 100 photons of light, only 14 are converted into electrons. Dye-sensitized solar cells are slightly more efficient. Here is the efficiency of other solar cells. Gallium arsenide is very efficient, problem is very expensive. The reason for splitting water is to use hydrogen as a fuel. Hydrogen is not used as a fuel in a car engine because the hydrogen combustion reaction does not produce work. Hydrogen will be used in a fuel cell, so stop the video and figure out how does the fuel cell work. So here's how it works. Hydrogen gets oxidized at the anode to produce H+ ions. The protons react with oxygen in a reduction reaction to produce water. Let's look at a fuel cell in more detail, so stop the video and answer these questions. So here are the answers. At the anode, oxidation occurs, and hydrogen is oxidized to H+. At the cathode, reduction occurs, so O2 is reduced to water. The proton exchange membrane allows protons to pass from the anode to the cathode. And the hydrogen fuel cell will produce 1.23 volts. This makes sense because it takes minus 1.23 volts to split water. The hydrogen fuel cell is an efficient device. When it's used in a car, the overall efficiency is about 64%. Compare that to a gas engine, which is only 20% efficient. A battery-powered electric car is actually more efficient than a fuel cell, but the source of the electricity will determine the overall efficiency of the battery-operated car. An application of electrochemistry is in biosensors. I'm going to guess 1 or 2 of you may work in this field in the future. You've seen rust before. Corrosion costs a lot of money. Electrochemistry can be used to get rid of rust. The iron in the rust can be reduced back to iron metal. Lead is a very toxic substance and is very dangerous when lead gets in water. These pictures show how lead got into the water. Note that corrosion inhibitors are important substances in keeping the metal from oxidizing to the metal ion, which can get into the water. If a corrosion inhibitor is not used, chlorine, which is used to disinfect the water, can oxidize the metal to the metal ion. So let's review. Stop the video and answer these questions. And here are the answers. For a voltaic cell, for an electrolytic cell, and to make a 1.5 volt battery, you would use zinc and silver. Review the table of standard reduction potentials and the video on batteries.